lines, I'm not sure what the material is that they put in there, but let's say strings or something. It matters how many strings are in there. Photons from reflection can actually flatten out to a certain degree, right? I don't know what that is, but let's say it looks like sort of a hamburger roll, and others are round. So again, what's happening is when the lights come through the material for the polarization, the ones that are basically look like hamburger buns, like coming off water. If you've ever been on the water, the sun comes off the water and it creates quite a glare. If you use a polarized lenses, right, it stops it. Why? It stops it because the photons are misshaped, and some of those won't go through, and others just hit the polarizing material, and they won't go through either. So it sort of depends. It depends on the number of light photons that deform, and it depends on how many lines of the material to cause the polarization is. But it has nothing to do with the light. Polarization has nothing to do with affecting affecting light, light waves or light. It has nothing to do with it, since what? Light travels in a straight line, right? So that's something else to think about. Don't look up at the sun with polarized lenses, because it doesn't stop. At that point, it won't stop anything. You don't want to ever do that. But, like I said, what it does stop isn't direct light. What it does stop is indirect light, which is what? Reflected light. And you can try this yourself on if you're out in the water sometime. So, I mean, that's sort of, hope you got the main ideas of that. And of course, the main idea about this is what? That in the visible light spectrum, right, the photons follow a straight line, ceteris paribus, other things being equal. They are spaced in a certain way, and each photon carries its own color. And this goes back to an earlier video I did as well. You can't change the color by changing the wavelength, because there is no wavelength to change. So light travels in a straight line. You don't need a wave, because they don't exist anyway. And here's several examples as to why what you're seeing, right? Waves don't scrunch or contract because there's nothing to contract. It's the addition of the source with the light, speed of light, that gives you the higher speed of light. And here, polarization has nothing to do, doesn't need the wave theory of light in order to work, right? It just, again, several examples as to why this thing works. So that's kind of it. And just for our scientific friends out there, I just add this little quotation. You must accept truth from whatever source it comes. And that's from Rambam, R-A-M-B-A-M, right? You must accept the truth from whatever source it comes, Rambam. And some of you will know who that is, others won't know who that is, but it's a good chance to do some research and understand a little bit of history. So that's it, and see you later. Thank you. $4 minutes.